Hello, everyone, and welcome to the 2025 PIBBSS Symposium. Our speaker, Annie Stephenson, will be talking about Dungeons and Dragons.
Yeah, not just Dungeons and Dragons, to be fair. There's also some AI in there as well. Um, but yeah, so today I'm gonna share the project that I started this summer through PIBBS, where I've been comparing human social systems to LLM social systems using the role-playing game Dungeons and Dragons. And um, this work has been done in collaboration with my PIBBS mentor, Jan Kolveit. And please feel free to stop me to ask questions throughout the talk. So uh, I prefer to make it as interactive as we can for a Zoom seminar, which, you know, may or may not work well. But yeah, so before we get into the project, I just wanted to give you a little context about how I came to this topic. So I did my PhD in applied physics, where I was studying light scattering in disordered materials made of nanoscale particles. And this work was largely experimental, but I was also doing a lot of theory work to explain the experimental observations. And this kind of philosophy of theory guided by experiment and guided by trying to explain experiment is kind of the theme that I have taken through all of my research. So for my postdoc, I switched fields to study human collective behavior and still taking some of the frameworks and things I learned from physics to study patterns, large scale patterns in human social systems. And over the past year or so, I have become interested in how AI is going to impact our human social systems. And this is what I've been working on at PIBBS. And so how are AI systems and more specifically LLMs influencing our social systems already? Well, I think one relatively well-known example is in how it's changed the way that we write or the products that are written. So there's been a bunch of papers that show how certain words that are favored by ChatGPT have kind of exploded in use in since the introduction of ChatGPT. So this is just showing how word frequency of words like delves have increased in PubMed abstracts. And so you can kind of explain this by just being like, well, maybe scientists are just using AI tools to write their papers now. So it's not necessarily impacting the social system in any real way. It's just showing that people are using AI to write. But I think this other study actually uh, challenges that and brings it a little bit further because this is showing a peak in the use of the word delve, not in writing, but in unscripted conversational podcasts. So I think this is really a bit haunting because it's showing not just that AI is affecting our writing, but it's affecting the way that we speak or maybe even linguistic norms. And seeing something like this um, brings to mind the kind of loss of human agency that is described by this concept of gradual disempowerment that was introduced in a paper recently by Jan Kolveit and other authors. And it's this idea that as we see incremental advancements in AI, we might see human agency sort of be chipped away at, maybe by having AI kind of change the trajectory of our culture or change economic patterns as sort of first steps, but this could get quite extreme if you take these increments to the very end. But so far, I've just been talking about ways that LLMs influence our society by really just through one-on-one chats, ChatGPT, where people are just chatting and maybe using it as a writing tool. But LLMs are starting to be deployed as agents in human social systems. So you can see this through social media, where we have some LLM run accounts that can actually interact in discussions and share information. You are also starting to have LLM agents that are capable of making purchasing decisions, actually buying things online. And I think these things could have actually quite a big impact on our social systems. And it's concerning because most safety evaluations are for thinking about these one-on-one human LLM interactions, but these are multi-agent problems. So, for social media, we have LLMs embedded in systems that actually impact our cultural trends, the way that information spreads, what articles or information becomes popular. And the presence of LLMs in our economic markets can change buying patterns and economic trends. And we need ways to evaluate and understand this. Um, and so the question that I'm interested in is, how does emergent behavior change when LLMs become integrated into human networks? And so to answer this, I think we need to have a better understanding, first of all, of how to measure human network social system emergence, and also think about the kind of opposite of that, of just having a purely LLM social network and what kind of behavior emerges, and then kind of bring those findings forward to try to understand what the mixed network can produce. So having humans and LLMs interacting together. To answer these questions is really a tricky task because, first of all, I think we need better ways to measure emergent behavior in social system. And we also potentially need ways to model it, because I think ideally you would want to have some idea of how these things will impact our social systems before they're deployed at large scale. But this is very somewhat controversial. So some researchers have called for using LLMs to actually simulate humans in social settings. So the idea could be, to answer this question, maybe you are using LLMs to produce some kind of simulated human, maybe through careful prompting or some kind of fine tuning, and simulating or modeling the interaction with just standard LLMs. So you have this mixed kind of system. But this is a somewhat tricky thing to do, because other researchers have shown that LLMs can fail to reproduce human-like responses to questions in social science surveys. I think it's pretty obvious that LLMs are going to miss nuances of human behavior. And I think we have to be extremely careful about trying to use LLMs as some kind of proxy for humans. And you have to decide kind of where and when and for what kind of dimension of behavior that even would make sense or be useful. But on the other hand, there's been a number of past studies that show interesting emergent behavior in LLM social systems, so purely LLM agents interacting with each other, that kind of resembles human-like behavior. So this is just one example where researchers had a social system of LLM agents interacting and seeded one of them with the idea to start to throw a Valentine's Day party. And without any external prompting, the agents just self-organized, spread this information, and actually organized a Valentine's Day party that people showed up to. And this is interesting because it does kind of feel like something that humans could do. So maybe there we are seeing some kind of social behavior emerge that is like humans. But how do you really compare something like this to humans? Because this is a simplified social world with a very pared down action space. And I think it's difficult to really know in what ways this kind of party throwing is similar to what humans would have done or different. And I think to really understand how emergent behavior of LLM groups differs from that of human groups, we need some kind of human baseline. And I am proposing that we do this using role-playing game data, and specifically the game Dungeons and Dragons. So Dungeons and Dragons is a collaborative role-playing game where people can build narratives together. It's quite open-ended, even though there are a lot of rules. Um, and I was able to use a data set that was collected by Chris Callison Birch at Penn, who's collaborating on this project with us. And it consists of 985 full games or campaigns, typically 4 to 8 players, but they can be larger in some cases. And these can be spanning hundreds to thousands to tens of thousands of turns. So some of these games actually span more than a year. So these really rich narratives can develop over time. So just to get a quick sense of what this kind of data looks like, and also the data set that I'm looking at is purely from text-based games. So that's kind of one of the advantages here where we can compare with LLMs, is that people are just posting their turns on an online forum. And so it's directly comparable with what LLMs produce. So in the games, typically you start with a initial dungeon master post, and the dungeon master is the person sort of running the game, and has the overall frame of what the story will be somewhat mapped out. And they'll give some general information about the game. They'll provide an initial game scenario, which kind of serves as the first real in-game post. And then each potential player will post something about the character, backstory, or name, sometimes with an image that they want to play, and also post their character sheet, which includes the stats and abilities of their character. And so let's look a little bit at the human data first of all. So I aggregated all of the games together just to look at some general patterns, to show you what kind of emergent behavior we can start to see. So first of all, I'm plotting the gaps between subsequent posts over time. And you can see that time is the time between posts is more likely to be short. There's clearly more weight on the left side of this plot. But if we plot it in a log-log scale, you can start to see some other features. So there's clearly kind of this large, broad peak between 6 minutes to 10 hours. And notably, there's this heavy tail. And when I say heavy tail, I just mean that it roughly decays as a line on this log-log plot. And I'm not fitting anything here, but just showing the general trend. And this tells us that even though short gaps between posts are more common, the longer gaps are also non-negligible. And this is something that uh, is seen a lot in data on human communication. It is a hallmark of the bursty behavior that human systems often show, where activity is basically clustered. So you'll have a bunch of events in quick succession and also have these long gaps where there's no activity. Um, so this kind of fits the kind of emergent activity patterns we might expect in a human system. Another interesting thing to look at is the number of words in a post. So here we can see that there's also this higher weight toward the left. Posts are more likely to be shorter. But once we plot this on log-log, you can actually see it has a different kind of tail. It's not falling off as a line on the log-log plot. It is less heavy. So this is telling us that the super long posts are relatively negligible. People aren't likely to write a novel in a post. And we can also look at these kinds of distributions across individual campaigns, and you can see differences in the distributions. And we can also look at them across individual users to see how different players have different activity patterns. But these kinds of activity metrics, they're relevant for thinking about how to set up LLM-based simulations. But what we're really interested in measuring is other kinds of emergent properties that might have important implications to how our culture or social systems might be affected by LLM. So as an initial pass, in this work, I took creativity and group cohesions as two concepts that are both tractable to measure and worth measuring. So there's been a lot of past work on how to measure emergent properties like creativity and group cohesion in text. Most of the creativity ones involve looking at distances between word embeddings in the text or looking at some kind of entropic measures of the vocabulary. And group cohesion measures typically are looking at how aligned the language becomes in a group, or things like turn-taking equality, whether one person is dominating the conversation or whether these are more equally distributed. One measure I want to point out is the divergent semantic integration, which I think this paper was really interesting because it's a relatively simple measure. All that it is you can take a chunk of text and look at the cosine distance between pairs of word embeddings, all of the pairs in the text, and take the mean of that and use this as the creativity measure. And the creativity score, the DSI calculated, correlates surprisingly well with the mean human creativity rating. So they also had human judges rating the creativity of this text. And it's actually surprisingly close to the correlation of a single human rater with the mean human rating. So even though these kinds of measures can seem oversimplified, they seem to be capturing or at least correlated with something important about how we think about creativity. Um, For the purposes of this um, preliminary work, I started with just 3 measures on the text. And so the first one is something I'm calling session semantic diversity. So I'm actually looking at the mean of pairwise distances between post embeddings in what I'm calling a session. So it's a number of posts. And these are embeddings at the post level, so they're sentence or paragraph level embeddings. I'm also looking at the sequential semantic shift. So this is the mean cosine distance between subsequent posts. And for group cohesion, I'm taking a simple measure based on the Jacquard similarity, which is basically just looking at the proportion of each player's vocabulary that's shared with the rest of the group and then averaged across all players. And when we look at these measures um, in the human campaign data, you can see they show these kind of roughly normal distributions, which I think is already somewhat surprising uh, because it seems to suggest that there is some kind of typical value that they're tending towards with some noise around that. And okay, so we've looked at a bunch at emergent behavior in human games, but what we want to do is compare these measures across human games to LLM versions of these games. So what I actually did was set up a multi-agent LLM framework that reproduces game for game um, each each campaign of D&D. And so the way this works is we start with the human game log and we input that into an LLM and also some analysis code. And this gives us descriptions of the characters as well as descriptions of the players where we're trying to kind of extract both the player info separate from the character info. We also extract actual character sheets based on the player's posts so that we have their stats and abilities. And then we take the initial scenario that the dungeon master posts, just this first kind of intro post to the game. And then I'm also looking at the turn order and the distribution of post links that describes the game. These, the character and player info is then fed into character agents, which will be used to play the game. And then the initial scenario is just written as the first post for the initial game log. Then we actually simulate the games by looping through the turns. So each turn in the LLM game matches the character for the turn order in the real human games. So for each turn, the character reads the game log, reasons through how they should respond on a scratch pad, then generates their post, the game log is updated, and then we go to the next player. And this ends up giving us our final simulated game log, which we can compare to the human games. So I just wanted to give you first a taste of some of the kinds of differences that we see across the human and LLM games. So this is just an intro character post. So the first post from these characters in character. And the left one is the LLM, or wait, the right one is the LLM, the left one is human. And I just highlighted here what I think are interesting parts that really show you the difference in feel between the humans and LLMs. So the human games tend to have a lot more nuance and weirdness in the humor so far. Um, and you can see this in this kind of long intro where this character is talking about feeling awkward in front of women and just being silly. Um, and then the LLM tends to be really action oriented, just trying to stay more on mission. And this is something that I saw a lot just reading through these games. But let's take a look at these games a bit more quantitatively, comparing against the humans versus LLMs. So I looked at three models from one from Gemini, OpenAI, and Claude, or Anthropic. And the first thing that I'm showing here is just the distribution of post lengths generated by each model. And you can see that most of the times the LLMs are overshooting the human post lengths by quite a bit, except for in the case of Gemini, which actually gets pretty close. And I'm prompting them in the same way for each model. And the way that I tried to get the post length to match closer to humans was by actually looking at the mean, median, and standard deviation and general shape of the human campaign, telling the LLM what the distribution should look like and asking it to, based on the context of the story, choose a post length that would be appropriate given these parameters of the distribution. What I noticed with Claude and ChatGPT is it just tends a lot closer to the median value, whereas Gemini seems to reproduce the spread a lot closer. And this is so far only from 7 full campaigns, so there's going to be a lot more data to show, but I think this still gives the overall trends quite well. Um, so now let's look at, oh yeah, and then okay, I also tried something to um, investigate how it would affect the emergent behavior, which is two different prompt conditions. So first of all, I was tried telling the LLMs to just play the character that they're supposed to be role playing. But I also tried including a kind of additional layer of role play where they're asked to not just play the character, but also play the human personality that was playing the game on top of that character. And the hope here was that it might actually help us to reproduce something more human-like in the emergent behavior. But this really didn't change things too much. So adding in the human layer of role play uh, so far has just looks like roughly the same distributions. And so now let's look at the actual emergent behavior scores about from the text. So first of all, I'm showing this cohesion metric. What we see is that mostly the LLMs are showing more cohesion than the human games by just a bit, although they do overlap pretty closely to the human games. And Gemini seems to be just a tad shifted towards less cohesion. Now, for creativity, this is just the session semantic diversity, the first creativity metric. I found that the LLM games always show significantly less creativity. This is also true for the other creativity metrics, which I'm not showing here. Um, and yeah, it didn't vary nearly as much across the different models as it did for other measures. So what have we learned from this work? So far, these preliminary simulations have shown that LLM agent Dungeons and Dragons games show less collaborative creativity, but potentially more group cohesion than the human games. But there's a lot of work to be done to, I think, make this result something more concrete and more defensible. So first of all, I plan to do a bunch of improvements to the simulation. So adding in more of the complexities of the D&D gameplay. So far, these have been posts that are building the narrative together, but don't include things like combat and dice rolls. I also have a lot of plans to work on the emergent metrics. So I definitely want to implement something more complex for the cohesion scores. I also think that it would be important to measure some kind of success of the campaign, whether that's dynamically through the campaign or just an overall score for the end. Um, I also think it would be interesting to either experiment with using base models to kind of get away from the helpful assistant kind of personality that you see emerging in the LLM games, and um, and also try feeding in some number of posts from the first few posts of the human games in the prompts to try to see if that changes the kinds of responses that are produced by LLM games and shifts them maybe closer to humans. And where I'm looking at this going longer term is in developing some kinds of multi-agent evaluation metrics. So, or trying to measure the kind of emergent behavior and evaluate how the LLM's behavior differs from humans and therefore how it might affect our human social systems. And taking this even a step further, I'm interested in trying to be able to shift with prompting the kind of LLM emergent behavior. And if it's possible to shift that closer to humans, to try to simulate these mixed human LLM these human LLM systems to see if we can predict ways that our social systems may be impacted. So with that, I just want to thank everyone at PIBBS. This summer was really amazing because of all of you. And in particular, I also want to thank my PIBBS mentor, Jan, who helped a lot with shaping the ideas of this project and giving me feedback at different steps. Dushan was my research manager for the summer and gave me also really great ideas and helped to shape this work. I also want to thank my collaborators at Penn who provided the Dungeons and Dragons data set. Chris and Andrew, this work also wouldn't have been possible without you. So yeah, with that, happy to take questions. Um, yeah, thank you.
I have a question. So if you go to the slide with the measures of creativity and group cohesion,
Yeah,
uh,
1 second. Um, yeah.
wait, maybe it was before. Oh, this is creativity.
I mean, this is the three measures that I'm looking
Okay.
at, but
What was the one with group cohesion?
oh yeah, it's based on the Jacquard similarity. It's literally just the proportion of each player's vocabulary that's shared with the rest of the group.
Yeah. Um, I was just saying, so like with the creativity ones, you say um they kind of like verified the metrics by getting humans to rate how creative it was. Do you know like if we have similar reasons to like support this Jacquard similarity?
Yeah, I don't think so. So, well, I shouldn't say that because I'm not fully familiar with the literature, but I think if I was going to, continue this work, what I would do is implement some of these more sophisticated measures of group cohesion, which I believe some of these maybe have been looked at in potentially not with human raters, but more with something about like the group success in completing tasks together. So like looking at how the lexical alignment correlates with their ability to work together effectively. So I think that's also a really good kind of human-based measure. But the measure that I chose was more just a quick and dirty initial metric that I wanted to get me close to something about lexical alignment, but it's by no means the ideal measure.
Okay. Uh, all right. I think there's a question
Yeah,
from.
we have a question from the audience. What do you think these kinds of experiments tell us about safety? Do you think it's desirable for agents to be human-like, for example? Or do you think it's good if they are more creative or have even better group cohesion than we do?
Yeah, I think this is a really difficult question, and it's one that I've been thinking about a lot because it's not at all clear to me that you want LLM agents to perfectly mimic humans because humans are also not very aligned in a lot of cases. So I don't know if we're the ideal thing to mimic. I also think it's really difficult to ask then what we do want from these agents. Do we want them to be more or less creative? I think that we honestly need a team of philosophers working on these kinds of questions because I certainly don't feel like I have the appropriate level of philosophical or social science background to answer the question of what we should be doing. But my thought is that at the very least, we need to measure it. We need to understand how, in their current form, LLMs can affect our behaviors. And then we can decide. I mean, ideally, there would be multiple people working together to think about these questions to decide to how we want them to affect us. And we can have a little bit of agency in that. So that's my kind of non-answer way of answering that.
Understandable. Cecilia, I don't know if that answers your question. I've allowed you to unmute if you want to follow
Uh,
up.
yeah, thank you. I think it does. Thank you.
Awesome. And then we have one more question. Have you tried playing or tinkering with the model temperature parameter to see if it influences the creativity metrics?
Um, so far I haven't. I mean, I just set a relatively high temperature for all the games. Um, yeah, that's something that I also think would be useful to do. It's just a matter of these games are really computationally intensive to run. So I haven't, run all the different parameters, but I think um, yeah, cranking the temperature up should increase the creativity. I don't know what that will do to the cohesion scores, though. It might decrease them. But yeah, definitely something worth trying.
Yeah, that's interesting. Hatim, I've allowed you to unmute if you want to ask follow-up questions. Cool.
No, I got what I wanted. Thank you.
Sweet. Yeah, it's really an interesting question of like what we should be aiming for. But yeah, good to have a measurement. So with PIBBSS supercluster, which we do not currently have, but if you had unlimited compute, what are things that you would try with this setup? Or what other setup would you try?
Yeah, I mean, I think first of all, I'm interested in how much you can change these kinds of scores. Like let's say also let's say not I don't just have the PIBBSS super cluster, but I also have the perfect metrics that I've come up with. That's also kind of its own project. But if I do have really good metrics, how much does prompting, scaffolding, fine tuning, or like kind of any tweaks we can make to how these LLMs respond, change these distributions to be more like humans or more dissimilar to humans. I think in the current version that I have, it's just limited to simple prompting. And I think that to really explore what the possible impacts of LLMs will be on social systems, we really need to explore the kind of limits of how much we can tune these things to reproduce our behavior. But yeah, I mean, I have like a lot, I could say more on this, but yeah, I think I kind of also just quickly outlined like the things that I'm interested in doing at the end. I think, yeah, taking it a step further, I'm interested in doing these kinds of simulations of, if we can somehow prompt or fine tune models to reproduce the kinds of emergent behaviors that we see from humans. Then what happens if we model together the LLMs that are standard prompting or not fine-tuned, that have just the instruct models with the sort of human simulating versions. And even it would be ideal if we could find experimental systems to compare to, but that might be really difficult to create or find.
Yeah, thanks. And one more question. The setting in D&D seems to be pretty much fully cooperative most of the time among the players. Do you know if any similar language heavy data sets exist for less cooperative settings? Are there role-playing games that exist like this? And what differences would you expect in the results in these different multi-agent settings?
Yeah, so that's definitely true. And that was a big reason, the cooperative nature of D&D was a big reason why we actually chose it. Another data set that I was considering early on was like Werewolf or Mafia. It goes by different names, but this is a game that is less cooperative. And I do, I kind of, we chose to go away from this partially because the instruct models that we're using are, that are trained to be super helpful and non-deceptive. We don't expect them to be great players at these kinds of more deceptive games, but maybe if we fine-tuned base models, or yeah, if maybe set up in the right way, it could be interesting to look at these more deceptive based games. I guess the question was, how do I expect the results to be different? I mean, I certainly think that the kind of group cohesion scores potentially could go down. This is also assuming we have good metrics for these kinds of things. Could also be useful to even have some kind of cooperative metrics to measure how well people are cooperating and maybe being kind to one another. But yeah, I definitely think that like if we want to understand emergent behavior from LLMs, we don't just want to look at cooperative games like D&D. Ideally, there could be both more mixed motive games, and also games with different kinds of goals. Another thing we were looking at potentially was escape rooms, text-based escape rooms. So these are still cooperative, but the goal is much more focused. There's a lot less need for narrative and having fun with the role play, which in some ways makes it could make it less interesting, but you could study different kinds of emergent things. So yeah, I think there's a ton of differences that could come out of studying different kinds of games.
Nice. Yeah, thanks. I will let Joss unmute if you'd like to ask follow-up questions or.
No, that was good. Yeah, thank you very much.
Awesome. All right, we are out of questions for now. I made Annie's after talk room, and you can go there and ask further questions. Yeah, after the talk. Thank you all for coming. Thank you, Annie, for a lovely talk. See you in 10 minutes for the next one.
Thank you. Bye.